Hello. Um, Welcome to my YouTube channel. Okay, yeah, this is recording. Good, because before it wasn't recording and that made me very sad. Alright, so today I am going to teach you how to do word problems. So all you have to know is this four words ax squared plus bx plus c, right? That is a quadratic function, and then you can always turn that into vertex form, which is a times x minus p squared plus q. This being the x value of vertex, this being y value of vertex. Now, I'm going to assume you already know that because you should. All right, so let's read the question. Madison stores her all-terrain vehicles, ATVs, in a storage shed. The walls and roof of the shed form a parabolic shape, right? So as you can see in my beautiful drawing over here, this is an ATV, and then it forms a parabolic shape, so I drew that, and it can be represented by a quadratic function, right? Because this thing here, this thing, oh crap, this thing here, that's a parabola, right? There's the vertex, there's the x-intercepts, and you can use your brain and connect the dots. All right, so the height of the building h in meters is modeled by h equal to negative, yeah, that equation, where d is the distance along the floor in meters from the edge of the building. So you're thinking, what the freak? What does h and d represent? This is distance, d. All right, hang on. Just think of this entire axis as distance, right? And this entire axis as height, right? Let me highlight that, right? But isn't that just the x and y axis, you may ask? Yes, that's the whole point of the question. Okay, moving on. So we are given this equation right here, right? So what can we do about it? First of all, why don't we put it into a form that we realize better? Now, if you use your eyes, you can connect it and see that, hey, doesn't those two look similar? Now, why don't we rewrite it down here? Instead of h, we use y, because in this scenario, they are the same thing. Instead of d, we use x, because in this scenario, they are the same thing. Let's rewrite it. Y is equal to negative 1/3 x minus 3 squared plus 3, right? Hey, will you look at that? That's literally just vertex form. Okay, so now that we have that down, let's look at the question A, or part A. Use graphing technology to determine the roots of the equation corresponding to the shape of the building. So what are the roots? Roots is equal to x-intercepts. So why don't we try to find them on the graph first? Now, where would they be? X-intercepts are where the points touch the x value, or the x-axis. And in here, x-axis is the floor, right? So where does this parabola touch the floor? It'd be here and here, right? But how can you tell the specific points? Well, you can always change this into this form. Okay, you get that? You just hashtag factor. Now, I'm going to assume you can factor, and I am extremely lazy. So, we will use Desmos. Hang on. Okay, we will use Desmos. Split view. Where is Desmos at? Okay, now we have Desmos open, right? So why don't we graph this? Because you can factor this out on your own, but I'm not going to do that. All right. Yo, what the sigma? Yeah, okay, that does make sense. All right. So, where are the roots? Y, I'm going to rewrite this into factored form. Y is equal to x minus 0, so that's just x, right? And the y, when y is 0, x is 6. So those are your x-intercepts, right? So what does this represent? The shed touches the floor at 0, and I'll change colors. At 0 and at 6, right? I'll draw 0, 0, and 6, 0, right? So, you have part A done. You found the roots. Now, how can you possibly apply the roots? Hang on, let's go back to the thingy-majiggy. Alright, it's on the right side, but deal with it. So, what is the width of the floor of Madison's storage building to the nearest tenth of a meter? So, let me redraw this to make it nicer. Alright, oh crap. Okay, let's redraw it to make it, actually, no, we don't need to redraw it, right? So the width, what's that? We're trying to find the distance. Let's make this bigger, actually. Oh, it's here. We're trying to find the distance between here and here, right? So how could we ever do that? Well, since we have the actual points on the graph, can we not just do 6 minus 0? Yes, we can. It's just 6 meters. All right, that's how you do the first question.